Hello everyone, I am Nitin. I am here with my team to present our project on embedded system. My team includes Nandini S and Fenin BS. We are from St. Joseph Institute of Technology, Chennai. Table of content, embedded system and category. In that embedded system and category section, we will see what is embedded system, what are the various components of embedded system and categories of embedded system requirements, applications of embedded system, and future trending of embedded systems. And in the microcontroller section, what we will see what are the peripherals which we will be used in the microcontrollers, like CLCD, matrix keypad, as well as we will break down the concept of microcontroller versus microprocessor. Finally, in interrupt and timer, we will see what is interrupter and what is timer, as well as we will see what is the flow of interrupter service routine and so on. And finally, we will see microwave oven demonstration. What is embedded system? Embedded system are a specialized computer system designed to perform a specific task. We can find these embedded system everywhere around us, like fan, car, refrigerator, mobile, TVs, and the wearable devices which we are using today. These can perform a specific task which will be given to that device itself. For example, in car, we had a ECU, electronic control unit, which will collect the data from the sensor in various parts of the car, and that will be processed and give a actual output to the actuators. Embedded system categories. Here we have a three categories, which are real-time systems, networked systems, and standalone systems. Real-time systems. These real-time systems are designed to perform a task within a restricted time. This system has to be completed the task or a process within a specified time to ensure the safety. Networked system. These networked systems are designed to communicate with each other or each devices or peer-to-peer devices via the networks which will be provided or wireless communications. For example, IoT sensors, industrial Internet of Things sensors which will monitor and control, and some of the healthcare units. And finally, standalone system. This standalone embedded system that operates independently to perform a specific task. This will not depend upon any external functions to give a specific output. Components of the embedded system. Embedded system has a three main components: sensor, microcontroller, and actuator. Sensor is responsible for collecting the data from the environment. It can be measure various physical quantities such as temperature, pressure, light intensity, and motion, and many more. These sensor converts this physical measurement into the electrical signals for the processor, so that the processor can be processed what the actual data is. This physical measurement to electrical conversion is happened by the ADC. The next component is microcontroller. Microcontroller is act as a brain of the system, which integrates the processing unit, memory, input output unit. Every unit can be connected or integrated within the microcontroller. This microcontroller is responsible for executing the instruction and performing the calculations. And the final component is actuator. Actuator are the component that translate the processed data which is processed by the microcontroller, and that will be actuated in the physical world. For example, the examples of the actuator may be a motor, display, or speakers. For example, the robotic arms are the actuators in embedded system. Like if we wanna capture the project components of the embedded system. Embedded system has a three main components: sensor, microcontroller, and actuator. Sensor is responsible for collecting the data from the environment. It can be measure various physical quantities such as temperature, pressure, light intensity, and motion, and many more. This sensor converts this physical measurement into the electrical signals uh, for the processor, so that the processor can be processed what the actual data is. This physical measurement to electrical conversion is happened by the ADC. The next component is microcontroller. Microcontroller is act as a brain of the system, which integrates the processing unit, memory, input output unit. Every unit can be connected or integrated within the microcontroller. This microcontroller is responsible for executing the instruction and performing the calculations. And the final component is actuator. Actuator are the component that translate the processed data which is processed by the microcontroller, and that will be actuated in the physical world. For example, the examples of the actuator may be a motor, display, or speakers. For example, the robotic arms are the actuators in embedded system. Like if we wanna capture the uh, project applications of embedded system. Embedded system play a crucial role in various industry, but see some of the application in automobile industry, healthcare industry, smart home industry, and industrial automation industry. Automotive industry. In automotive industry, the embedded system can control the car functionalities like engine control system and brake systems and so on. In healthcare systems, for the implementations of diagnostic equipments, embedded system plays a vital role in the monitoring patients. In the we see the pacemaker. Already we have seen the pacemakers. For in the home automation, the embedded system brings the automation and connectivity to our homes. Like we already see the controlling of lighting, temperature, controlling of lighting and temperature. Also ensure the security in our home. Finally in the industrial automation, we can optimize the process. Like we can monitor the machineries, how old the machinery, how the functionalities of the machineries we can be measured, so that we can increase our productivity and quality as well. Real-time aspects of embedded system. We had two real-time aspects: hard real-time and soft real-time. Hard real-time tasks must be completed within a specified deadline without any exception. A missing of deadline in a hard real-time system can have a severe impact or often gives a catastrophic consequences. For example, in automobile or automotive applications, controlling the airbag or anti-lock braking system must occur within a precise time to ensure the safety of the passenger. Soft real-time. Soft real-time systems have a task with the time requirement, but they can tolerate the occasional deadline issues without any causing of system failure. These tasks are considered as a time sensitive but more forgiving compared to the hard real-time task. Here in the soft real-time system, missing a deadline in a soft real-time system may result in a degradation of system performance or users experiences. Design considerations for developing embedded system. Here we mentioned only three concepts, but the design consideration for development of embedded system may be very vast than we think or than we explained here. Power consumption. For every embedded system, the power management feature is enabled in a particular embedded system for managing the power that will give or that will schedule what component or when the component has to be powered on or off. This power management or power consumption reducing can help the extension of battery life. And the next main thing is cost effectiveness. Optimizing the resource and production process to develop cost effective embedded system that meets performance and reliability requirements are well featured in the cost effective of a given embedded system. Scalability. Scalable embedded system often employ a modular design approach, where the components or the subsystem of an embedded system can be easily replaced or upgraded without any effect for the entire system. Introduction to microcontrollers. Microcontrollers are the compact devices which can be used as a central processing unit for the embedded systems, and these versatile electronic components has a integrated processor, memory unit, input output ports, and other external peripherals within the system. These microcontrollers are designed for a cost-effective solutions. By consolidating the critical elements into a single IC, they reduce the need for the external components, which lower the production cost and enhance the reliability as well. Efficiency of the microcontroller are optimized for a specific task so that it can perform highly and effectively. In microcontrollers, all the peripheral ports are within the microcontroller, so it can also used as a compatible sizes productions, and it will be placed within a given constrained location, or which has a unique sizes to compact our system. Difference between the microcontroller and the microprocessor. As I said before, microcontroller is designed for a specific task, which has a integration between processor, memory, and external peripherals, and so on. Also, it's used for a cost effectiveness, which will be used as a low powering system also. But the microprocessor is designed for the general purpose, uh, which can be used for various workstations or work locations we can be offered. We can multi-thread this microprocessor. We can perform various tasks within a given time. Also, the performance of a microprocessor is more than the microcontroller, because it has a more core extension to perform each instruction within a given time and give more performance out of microcontrollers. CLCD, or character liquid crystal display. These displays are used for displaying the all ASCII characters as well as some of the special characters. This CLCD has two modes, 4-bit mode and 8-bit mode. In our project we used 8-bit mode. Also, these CLCD are the output devices which can show the output for the users from the processor will give the data, and the data can be displayed in the CLCDs for the output purpose. Matrix keypad. These type of matrix keypads are arranged using the rows and column concepts to ensure which key is pressed at a particular point of time, so that we can sense which key is pressed at which particular point of time. We can be sensed using this rows and column concept. These matrix keypads can be found in telephonic keypads, calculators, and digital clock as well. Here we use in a microwave oven project for input purpose.
I am Fenin BS from St. Joseph Institute of Technology. I am excited to talk about fundamental concept in microcontroller programming about interrupts. Let's begin with the basics of interrupt. Interrupts are a crucial concept in microcontroller programming, and they serve as a bridge between our microcontroller and external world. Interrupt enable our microcontroller to respond to external events or tasks. They are like a tap on shoulder that says, hey, something important just happened, pay attention. So, how do interrupts actually work? When an external event occurs, it triggers something called an interrupt request. This event interrupts the normal flow of the program the microcontroller is running. The microcontroller temporarily suspends its current task to handle this interrupt. Now, let's see the interrupt service routine. In interrupt service routine, there are 4 stages. In first stage, the internal or the external device will request the MCU to stop the process. From the microcontroller side, in the stage 2, the microcontroller unit will acknowledge the request, and the microprocessor attends to the request and goes back to the processing where it was interrupted. This was the interrupt. Now let's see the classifications of interrupt. The interrupt is mainly classified into two types. The first type is hardware interrupt, and the second type is software interrupt. In hardware interrupt, it is further classified into non-maskable interrupt and maskable interrupt. And the maskable interrupt is further classified into two types. The one is external interrupt and the other is internal interrupt. The hardware interrupts are initialized by external hardware devices or signals. When something significant happens, like a button press or sensor reading, these external events trigger the microcontroller's interrupt system to handle them. Next, we have non-maskable interrupt. The non-maskable interrupt are crucial. They cannot be disabled or masked by the microcontroller. They are reversed for vital events that requires immediate attention, such as hardware fault or power loss. On the other hand, we have maskable interrupts. Maskable interrupts can be temporarily disabled or enabled by microcontroller's interrupt control system. This allows us to control when and how these interrupts are handled. Now let's see the interrupt service routine. An interrupt service routine is a specialized function that handles interrupts generated by external hardware device or the internal sources. Interrupts can be triggered by various sources, including external hardware peripherals like timers and internal events like system fault or specific CPU instructions. When an interrupt is triggered, the currently executing code will be stored in stack memory, and the execution of the code will be continued when the interrupt is over. Now let's move on to the next concept, timer in microcontroller. Timer are hardware components within microcontrollers that allows us to measure time intervals, generate precise time delay and trigger events at specific time intervals. Why do we need timers in microcontrollers? Think about tasks like measuring the duration of an event, creating accurate timing for the event, or scheduling periodic actions. Timers are essential for achieving these functionalities. Let's dive into how timers works. A timer consists of a counter and clock source. The counter increment or decrements with each clock cycle. By configuring the timer setting, we can determine when it should trigger an interrupt or some specific actions. The resolution in the timer is used for the register width. The tick is used for the timer to up count or down count. There are two types of mode. One mode is called counter and the other mode is called pulse width modulation.
Hi, I am Nandini from St. Joseph's Institute of Technology, Chennai. Now I am going to explain the simulation of our project Microwave Oven. Microwave oven is a common household appliance used for cooking food, and it is an example of embedded system. It consists of microcontroller or microprocessor, then sensors, control algorithms, display and user interfaces. Now for the requirements we uses MPLAB XIDE as a cross compiler and PixSimLab for the simulation of microwave oven. Now here is the PixSimLab. For the board we uses PicGenius, and for the microcontroller we select PIC16F877A. In the clock frequency we select 20 MHz, and in the LCD we select 16x4. Now I am loading my hex file in the PixSimLab by selecting file and then selecting load hex. Now the oven is powering on. Now in our project we are using 4 modes for cooking food. We can select the required mode with the help of matrix keypad switch. Now I am pressing 1 so that the micro mode turns on. Power is equal to 900 watt gets displayed. Micro mode is used for cooking foods like rice, soup and so on with the help of microwaves. And now we are setting time in the format minutes and seconds. I am taking some random time. If we entered the minutes or seconds wrong, then we can clear it with the help of star key, and now I am pressing hash to enter. Now we can see that the timer gets turns on and the fan starts rotating as the microwave oven started its cooking. And in the display screen we can see that there are start or resume, pause and stop. Now I am pressing the switch 4, and now we can see that the time gets increased by 30 seconds. Then the switch 5 is used for pause. Now I am pressing the switch 5 so that we can see that the timer is stopped and the fan is also stopped, and we can resume the operation by pressing the switch 4. Sometimes we may feel that the cooking is enough before the timer reaches 0. At that time we can press the key 6 so that the entire operation gets stopped. Now the second mode is grill mode. Grill mode is mainly used for browning, toasting, making sandwiches and so on, and it is mainly used to achieve a grilled or crispy texture on the surface of foods. I am pressing key 2 so that the grill mode is now turned on. Now I am setting timers 8 seconds so that we can hear the buzzer sound once the food gets cooked. Now I am pressing enter. And the timer gets displayed on the screen. Now the third mode is convection mode. By pressing key 3, the convection mode starts working. In convection mode, a consistent temperature is maintained throughout for even cooking and braining of food. It is mainly used for baking and roasting, baking cakes, cookies, breads and so on. Now I am setting the temperature, then pressing the key enter. Now we can see the time remaining so that the temperature is maintained for some 18 seconds. Then it is similar to setting time. If we don't need buzzer, then we can turn it off. The fourth mode is start mode. Start mode is used for heating food up to some 30 seconds. Now I am pressing key 4. We can see the timer starts from 30 seconds and it starts decrementing. Thank you.